We are living right now in an era of unprecedented digital overload. I mean, think about it. Attention fragmentation, chronic stress, sleep deprivation. It's essentially the modern American baseline. But what is this relentless lifestyle actually doing to the physical, biological structure of our brains? Well, welcome to this deep dive explainer. Today, we're not just going to look at the damage. We're going to explore how we can bioengineer our daily habits to fight back. We're going to map out the incredibly interconnected health systems of your body, from the microbes in your gut to the architecture of your deep sleep, to understand exactly how your lifestyle choices are quite literally remodeling your brain right this very second. So let's start by shattering a massive, pervasive myth. For a huge chunk of the 20th century, the consensus in science was that the adult human brain was a static, hardwired organ. The idea was basically that once you hit a certain age in early adulthood, your neural architecture was set in stone. You've got what you've got. But modern neuroscience has completely, absolutely overturned this assumption. Your brain is not a finished product. It's a highly dynamic, continuously adaptable system. It is very much still under construction. To truly optimize our cognitive performance and our long-term health span, we are going to walk through an interconnected systems framework today. We'll start by unpacking that dynamic brain myth, then look under the microscopic hood at the architecture of neural rewiring. From there, we'll decode the neuromodulators required for deep work, dive into sleep as the master optimizer, explore the physical foundations of movement and nutrition, and finally, synthesize the whole shebang into a blueprint for healthy aging. Let's jump right into Section 1, the dynamic brain myth, and shattering that fixed brain illusion once and for all. The absolute cornerstone of this masterclass is neuroplasticity. Now, you hear that buzzword thrown around a lot, but what does it actually mean? It is your brain's remarkable capacity to adapt its structure and its function in response to what you experience and learn throughout your entire life. This isn't just a software update where existing synapses fire a bit more efficiently. No, this is a structural hardware change. Your brain is physically altering its architecture. It's changing dendritic branching, it's forging new synapses, and yes, it is even generating entirely new neurons well into adulthood. An understanding that physical reality brilliantly highlights a huge misconception today. You see, millions of people relying on these commercial brain training apps, swiping on their phones, hoping to boost their cognitive capacity with digital puzzles. But evidence-based plasticity, it doesn't actually happen staring at a screen. Real structural brain health comes from things like aerobic exercise, which physically increases blood flow and promotes neurogenesis. It comes from meditation and from deep, complex social engagement. That's the real brain training. Moving into Section 2, let's zoom in a little closer and look at the architecture of neural rewiring, right inside the biological engine of your mind. At the very core of how you learn and adapt is something called the Hebbian principle. It's the classic use it or lose it rule of biology. When your neurons fire together repetitively, their connections get stronger, a process known as long-term potentiation. But on the flip side, a lack of activity weakens and eventually eliminates those connections entirely. Think about what that means. The habits you sustain every single day are physically carving out specific neural highways in your head, while the skills or knowledge you ignore are actively being pruned away into nothing. Now, if we look at the exact molecular machinery making this happen, it's mind-blowing. Look at these AMPA receptors. They are these highly dynamic protein channels that act as the ultimate gatekeepers of synaptic strength. When you have patterns neural activity, like when you're deeply focused on learning a new skill, these AMPA receptors physically shuttle into the membrane to strengthen the synapse. If you stop practicing, they are removed, weakening the connection. It is an incredibly precise, activity-dependent, microscopic dance happening in your brain right now. But neuroplasticity doesn't happen in a vacuum. It brings us to Section 3, neuromodulators and deep work, the chemical cocktail of focus. To actually trigger those AMPA receptors and rewire your brain, you need the right chemical environment. Enter the dopaminergic system. Originating deep in areas like the VTA, dopamine is fundamental for reinforcement learning and working memory. It's not just a cheap reward chemical. It's the gatekeeper for what information even gets access to your conscious perception. Through distinct receptor types, dopamine determines how we process behavioral rewards versus how we sustain grueling, deep cognitive work. Without optimal dopamine signaling, maintaining true focus is literally impossible. And working right alongside dopamine is the noradrenergic system, which runs on norepinephrine. Projecting from a tiny brainstem region called the locus coeruleus, this system is basically your brain's network reset button.
When you encounter something unexpected or you're forced to navigate a brand new environment, this system triggers a massive reset, amplifying your signal-to-noise ratio. It makes you highly alert and forces your neural networks to adapt to the challenge right in front of you. But here's the catch, and it's a huge problem in our modern world. Both dopamine and noradrenaline operate on an inverted U performance curve. If your levels are too low, you're drowsy, you're distracted, you just can't focus. If you hit that optimal middle zone, boom, you achieve peak focus and deep work. But if those levels are too high, which is exactly what happens with chronic modern-day stress, it results in debilitating cognitive noise. Your prefrontal cortex basically shuts down, leaving you highly stressed and completely impaired. So, how do we regulate that chemical cocktail? That brings us to Section 4. To understand focus during the day, we absolutely must understand sleep at night. Sleep is the master optimizer, our consolidation and detoxification phase. Sleep is not just a passive off switch for your body. It's an intensely active neurological state. As you cycle through the night, your brain is checking off distinct biological tasks. First, in slow-wave sleep, when your acetylcholine levels drop, your brain literally flushes out accumulated metabolic waste from the day. Then, during REM sleep, it switches gears into neural repair. It systematically reactivates the pathways you use while awake, stabilizing the new synaptic networks you want to keep and selectively pruning the ones you don't. And honestly, this next part is terrifying if you routinely skimp on rest. Without sufficient sleep, the delicate balance of that pruning process gets completely wrecked. When you are sleep deprived, your microglia, which are your brain's resident immune cells, become hyperactive. Instead of just cleaning up waste, they start aberrantly engulfing and eating away at your healthy, functional synaptic connections. Your brain's immune system literally starts digesting its own healthy architecture. Now take that sleep deprivation and mix it with chronic daily stress. It's a disastrous compound effect. Chronic stress floods your brain with cortisol, and over time, constantly elevated cortisol levels will physically shrink your hippocampus, which is your primary memory center. It directly antagonizes the healthy neuroplasticity we're trying to build, suppressing the birth of new neurons and actually promoting neuronal atrophy. Let's shift gears from the damage to the solution in Section 5, movement, nutrition, and plasticity. These are the physical foundations of a healthy brain. Remember those commercial brain games we talked about earlier? Well, compare that to the clinical data on actual physical movement shown here. Aerobic exercise literally drives angiogenesis, the creation of new blood vessels in the brain. It can physically increase the volume of your hippocampus by 1 to 2%. Resistance training can enhance executive performance by up to 18%. Even mind-body practices like yoga or Tai Chi are proven to increase gray matter density. You want to build a better brain, you have to move your body. And of course, you have to fuel it correctly. Your gut health and your nutrition provide the literal metabolic substrate for plasticity. Every system talks to every other system. Managing your glycemic load, even avoiding highly reformulated breads, can drastically reduce systemic inflammation, which in turn protects your sleep architecture. Consuming caffeine too late wrecks your melatonin, and incredibly, digestive hormones like leptin actually interact with receptors in your brainstem to modulate things like sleep apnea. Your diet is a powerful, direct neuromodulator. Okay, let's bring all of these distinct pieces together into Section 6, a practical blueprint for healthy aging. Let's synthesize these systems into a roadmap. The most empowering takeaway from all of this modern neuroscience is that getting older does not automatically equal cognitive decline. That's a myth. The evidence shows that in normal, healthy aging, the number of synapses can actually increase in your cortex. Through natural neuroplasticity, a healthy brain brilliantly compensates for the natural loss of neurons by simply forging new synaptic connections, allowing you to maintain sharpness and lifelong vitality. So how do you ensure that happens? By actively pulling these specific, evidence-backed levers every single day. Optimize your sleep hygiene to get those 7 to 9 hours, protecting your synapses from being pruned. Radically regulate your stress. Just 10 minutes of daily breath work or mindfulness can lower that neurotoxic cortisol. And lay down that physical foundation through regular aerobic exercise and mindful eating. When you do this, you are no longer a passive passenger to aging. You are actively directing your own neuroplasticity. Because here is the absolute core of the science we've unpacked today: the interconnected brain cascade. You cannot isolate one habit from the rest. Your physical activity fuels your brain's structural capacity, which helps regulate your stress response, which then optimizes your nighttime sleep architecture, which ultimately gives you that perfect neuromodulator balance to achieve deep, focused cognitive work the very next day. It is one beautifully integrated system.
So, as we wrap up this explainer, knowing that your brain is dynamically rewiring itself right this very second based on the information you just absorbed, I want to leave you with a direct challenge. Understanding that your daily habits are the literal architects of your neural networks, what is one specific lifestyle input you are going to change tonight to bioengineer a better brain for tomorrow? Thank you so much for joining me on this deep dive into the science of the interconnected brain.